Hello everyone, in today's video I'm going to be starting to design a 1/24th to 1/25th scale RC chassis that will be compatible with variants of the MA10 axle assembly. This chassis will be a nice alternative to mounting the individual components to a pre-existing chassis from a model car kit, like what I've done with the Firebird build. Although this setup won't look as scale, it will be a lot easier to assemble, and there won't be any worries about alignment and fitment during assembly. For this video, I'm just focusing on the rear end of the chassis. The plan right now for the front is to make it a flat surface for different kinds of modular front suspension, steering, and motor mount setups to be mounted to it. A little bit like the chassis I'm using for the Subaru build. I'll be covering the front suspension and chassis design in a future video. The requirements for this chassis is that it needs to be simple in design, can fit a variety of different size 1/24th and 1/25th scale bodies, and can be printed on a typical FDM 3D printer. This final requirement is quite important and will play a big part in the overall design of this chassis, particularly the rear section. If you take a look at the undercarriage of a typical car, the section behind the rear wheels is almost always higher than the section in front of the rear wheels. If a chassis with this design is being printed right side up, there is a lot of surface that is not being printed straight onto the print bed and will therefore require a lot of support, which will likely leave a rougher surface on these sections. One solution for this, and is the one that I'm going to be trying out, is to split the model as shown so that it will be in 3 separate pieces. With this model in 3 separate pieces, each piece has a nice flat surface that can be printed directly on the bed, which should make printing easier. This chassis will also be able to be printed on smaller build platforms, require less filament due to the reduced amount of support material required, and there won't be as many rough surfaces on the underside of the chassis. One downside though is that the overall strength of this chassis would likely be better as one solid piece, but I'm confident that this chassis will still be plenty strong. On top of that, it wouldn't be any trouble to modify the design to be one solid piece if desired. With this idea in mind, I began working on the design. Within Fusion 360, I imported all of the components that I will be building this chassis around, such as the MA10 axle and relevant suspension links. This chassis will allow for both a torque arm suspension setup like what I'm using on the Firebird, as well as a 3-link suspension to be used as well. At some point, I'd also like to design some similar chassis that allow for more kinds of rear suspension setups. At this time, I'm not overly concerned about the suspension geometry. For now, I really just want something that works. I'm making the upper link for the 3-link suspension about 70% of the length of the lower link, which seems to be pretty standard on full-scale street cars, and I figured it'd be a good starting point. And at the ride height that I plan on running, these links should sit around parallel with the ground. After figuring out the position of the upper and lower linkage mounts, I started to design the side profile of the chassis. I begin by sketching the shape and the angles that I want, and keeping in mind that I need to make sure that there is enough room to access the screws that will be securing the links. I then started to offset certain elements of the sketch to add thickness. I decided to go with 1.5 millimeters as the overall thickness for the flat sections of the chassis. After finishing the side profile design, I began extruding elements from the sketch. I made sure that the lower trailing arm mounts have plenty of clearance, which is something that is especially important to keep in mind when designing parts that will be printed on a wide variety of different FDM printers, especially on lower end machines and ones that are not perfectly calibrated. Fortunately, this would not be a very difficult area to do a bit of sanding and post-print finishing in order to ensure that the trailing arms can move smoothly. The overall width of the chassis is something that I will probably modify in the future, as well as make a few different sizes so that bodies with different widths can fit. I noticed that the position of the upper link was a bit low when compared to where the drive shaft is going to be, so I just adjusted its position a little bit. The next thing I did was make a cut from the top that will allow room for the wheel. The axle assembly that I have in this design is wider than what most bodies will require, so I wanted to make sure that I have plenty of room for both larger wheels and for narrower axles. After that, I wanted to make a cut so that the drive shaft, and if equipped, the torque arm have enough room. At this point, I wanted to make it so that the top piece that connects the front part of the chassis to the back section can be secured using screws. I made the screw holes quite small, only requiring a M1 by 3mm screw. I'm hoping that this is enough to make a strong connection between the pieces. However, if I need to modify the design to accept larger screws, that can be done without much hassle. I extruded sections of the sketch in 2 separate bodies, which I split and then combined with the chassis pieces. Since this area isn't long enough for a screw, I'm making this a guide instead of a screw hole. With the left half looking good, I mirrored each of the parts and combined them. For a little bit of added strength and support, I did a bit of reinforcement around the upper link mount. Next, I started working on the upper spring mount, basically duplicating the same mount that is located on the axle. After that, I made the panhard mount. I decided to modify the back end just a little bit by making it curve in slightly. I also added some tabs to the top piece that should further help secure it to the other sections and possibly add a bit of stiffness as well. Here's where the chassis is right now. Aside from a few minor modifications I'll likely be making to the rear section, such as making a cutout in the back that will allow for a deeper trunk pan-like piece to be installed, which will give more room for electronics, and a few other minor modifications here and there, this section is ready to be printed, and I will be doing so after I finish designing the front section, which I will be covering in a future video. I plan on using this chassis on the 1/25th scale 83 Camaro project, and on this 1/24 scale 85 Mustang I painted a while back. I'm sure I'll also be using this chassis under a lot more vehicles as well in the future. Anyways, thank you all for watching. I hope you enjoyed this video and it's given you some ideas and inspiration. I've got a lot more speed modeling videos in the works, so be sure to stay tuned, and I will see you next time.